null when we first introduced stats. And independent was two things that are completely unrelated. Dependent is when they are connected somehow. And so when I'm talking about dependent samples, I'm talking about two samples that are related in some way. So in order to do this, we're usually looking at matched pairs data. Do you guys remember hearing the terms matched pairs before?
I remember it.
Remember it? So the data was paired up. It might be that I gave you a pre-test and a post-test, and I took your two scores. So that data is paired because it's your data from two different instances. Or maybe I put you with a partner and you did an activity, and then I compared the scores of the two partners. That's matched pairs because you were in a group together. All right, so if we are looking at matched pairs data, we have two sets of data, but they can be paired up in some way. That also means it has to be the same number of points in both. So if I have 10 values from the first set, I would have to have 10 values from the second set in order for them to be matched pairs. So we are looking at this dependent data. Our requirements has to be matched pairs, normally distributed, or n is bigger than 30 because we're talking about the mean from the two sets. So the same requirements we've had for the mean all the way through. They have to be independent. Basically, same as we've stuck with in the past. The only criteria I'm going to really ask you to verify is that it's either normal or n is bigger than 30. And we will have to pay attention. Tomorrow we'll talk about what to do if I just have two unrelated sets of data. So we need to kind of get in our minds when I give you data and say, okay, are these totally unrelated or are they paired up? And that will impact how we set up our null and alternative hypotheses as we go through here. So first step is to set up null and alternative hypothesis. Null is always equal to, this is this thing that will be different from today and tomorrow. When the data is in matched pairs, what we're actually going to do is look at the difference between the first set and the second set. And so then we'll do all of our hypothesis testing based off that third thing, the difference between the two. And we'll do it just like we did before. So if I'm talking about the mean, we go to stats, test, looking at a t-test. But it'll be based off the difference of the two. So the null is going to be that there is no difference. The mean of the difference is 0. And then we can have less than, greater than, or not equal to. And we'll have an alpha level given to us in the problem. And we know we reject when what is true?
H sub 0 is less than alpha.
When the probability is less than alpha, we
Yes,
reject.
yes.
If the probability is bigger than alpha, we fail to reject. I went ahead and left on here because some years, if I have more time, I kind of teach the different approaches and how to calculate it. We're finding a t-value, but it's all based on the difference. So we have that third set, we're looking at the mean and standard deviation of that difference. That's how the t-value is set up. And then we look at our calculator. So I actually just want to jump straight to an example and talk about it. So the data represents the cost of a one-night stay in a Hampton Inn hotel and La Quinta Inn hotels for a random sample of 10 cities. Okay, test the claim that Hampton Inn hotels are priced differently than La Quinta hotels at the alpha equals 0.05 level of significance. So, I hear some of you already typing and you're probably guessing. What do you think we're going to do with our data?
List.
Put it in our list. So you can go ahead and enter it into your L1 and L2.
Circle ahead, my favorite color pen of yours. The brown guy.
All right, so did everyone get it entered in your two lists? All right, let's take a second and write down a few things. First of all, criteria. Do I need to really verify anything? Yeah, I already told you it was normal, so we're good there. We need a null and an alternative hypothesis. Okay, we are talking about the average price here. So the null is going to be that there is no difference. So we say the mean of the difference equals 0. And I guess I should maybe dwell on that for a second. How come I know this is matched pairs data? Why? How are these points related?
They're all in the same city.
They're in the same city. I took one city and took 2 hotels in that city. Okay, so that's why it's paired up. If I had just took 10 random from each and not from particular places, then they would be independent. But because it's one city and I compare the prices, that's what makes it match pairs. That also makes it very important when you put it in the calculator that you do it in order. We're thinking of these as ordered pairs, essentially. So you need to make sure if you skip one, you go back and put it in order on your list. What alternative am I testing?
No.
Not equal. Okay, so what we're going to do here, couple ways of doing it, but probably the easiest way, we want to compare the difference, right? So we could go to L3. The difference just means we do what with these values? Subtract. So we could go through and subtract every one of them, or we can use our smart calculator to do it for us. If you go up onto the title, L3, have fun. We are going to type in, I want to do list 1 minus list 2. And we're always going to do it this way, the first minus the second. That way, it was almost dangerous. So we're always going to do the first minus the second. If you flip them, it will change some of your values. So we're going up on L3, and I'm going to type list 1 minus list 2. So if you do second, number 1, you'll notice it down here, it says L3 equals L1 minus second number 2. So list 1 minus list 2. And if you hit enter, it will automatically subtract all those for us. And so we don't have to do it. As a little side note, if you were, like, I could ask you questions about that set. If I asked for, like, the mean of that list or the mean of the difference, we've done that in the past. Remember when we go into, like, our one variable statistics? You guys remember doing that? So if I asked you to find, like, the mean of that list, you could very easily if you went back to calculate one variable statistics, but which list would I want it to be based off of? 3. So you could change that to list 3, delete anything else, and calculate. And we could see, okay, the mean of that is 51. So does that seem like it's probably going to be 0? It's kind of iffy. Standard deviation, we have all this stuff you can find on your calculator if you were going to do it by hand. And that was in our one variable statistics, like we did back at the beginning. But what we want to do is a hypothesis test. So let's go into stat tests. I have turned everything, I have 2 separate lists and I've combined them into one. And if I'm talking about a mean, what test are we doing every time? The t-test. So we're going to go back into number 2, stat test number 2, just like from yesterday. But list, mine guess what I was going to do here because I already changed my other thing. Your mean of the null is 0. Your list should be set at L3. Everything we've done before is L1 because we only had one list, so you do need to change this L1 to an L3. So if you just do second number 3, that would change it. Frequency should be set at 1. We are testing not equal. So, the work I would ask you to show, we are doing this on our calculator, so there's not a ton to show. On test or quiz, it would be helpful if you at least told me, where we went on stat test. Number 2. We got a t-value of, 5.271. And our probability is, yeah, make sure you watch at the end that E-4 moves your decimal back 4 places. What'd you say?
5128.
So when we look at that, that is an extremely small probability. Yes.
It's not showing up.
Okay.
It's showing.
Did I give you an alpha level on this one?
Yep.
0.00. So we kind of already anticipated when we looked at the statistics for that variable, we saw it had a mean of 51 point something. So we kind of already guessed there was a difference. This is showing us my probability is very small. So since p is less than alpha, what does that mean?
Reject.
Reject the null hypothesis. If I asked you to write a sentence explaining what that meant, we'd say there is sufficient evidence to conclude the hotels are priced differently. Can you tell me which one's more expensive based off?
New Hampton.
When I did my difference, and when I brought up the one variable statistics for that, my difference was positive. That means L1 was bigger, so my Hampton is more expensive. If we had a negative, that would mean the second one was more expensive. All right. So basically our goal here is to take the two sets of data, combine them into one by looking at the difference, and then we do it just like before. Do our t-test and comparing our p and our alpha.
There's too much space to work these out.
So if I were showing you control approaches.
Oh, I got you.
All right, we've also talked about doing confidence intervals for these, so we could still use that confidence interval approach. If I asked you to test the same thing with a confidence interval, we know the null, I'm just writing it down again, we have it on the previous slide, we're assuming no difference. The alternative, we were assuming not equal. So if I wanted the 90% confidence interval, we go back to our calculator. We're going to go to stat tests, and which one did we do for the? If I'm doing the t is the hypothesis testing, confidence interval is the t interval, which is number 8. So stat tests number 8 to create a confidence interval here. We do need to make sure that it's based off the data because we did have the two sets of numbers. My list is L3 because I'm looking at the difference. That was the third list. Frequency should be 1. Confidence level, I said 0.9. So that is my confidence interval. And how do I use that to test my hypothesis?
Does your thing fall in it?
The null is 0. Is 0 in my interval? No. We are 90% confident the real value falls between them. So, since 0 is not in the interval, we reject. So we can do our hypothesis testing or confidence interval to decide. I hear some of you have books in here. I want to pull a couple examples out of our books to look at. So if we could just grab a book on the counter, you can share with someone if they're not all in here.
we have like the extra boxes.
Yes. I just got
You just knew.
knew what I was
knew what
gonna
you
do.
were gonna do. That's
Crazy. I read my own mind.
I'm glad we were saying the same thing there for a minute. Close the XLS stat or the Excel stat added to your Excel.
Oh,
No,
yes.
no thank you. Pass.
Alright, so we are going to look first, probably going to do two examples out of here. I want to look at problem number 9. So it's commonly held belief that SUVs are safer than cars. If an SUV and car are in a collision, does the SUV sustain less damage as suggested by the cost of the repair? Okay, so the Insurance Institute for Highway Safety crash SUVs into cars. The SUV was moving 10 miles per hour and the front crashed into the rear of the car. So it's telling us a particular accident, how much damage was sustained on the SUV, how much was on the car. Why does that match pairs data?
Because they're touching the same car, like the brands.
Well, it's that they are the same brands. What else is true?
It's the same crash.
It's the same crash. I didn't go run an SUV into one thing and the car into something else. They ran into each other, so they were involved in one crash together. So that's why it's matched pairs. So on your calculator, you want to clear all of your lists. Remember, clear, not delete. And enter your data in order. And then what do we do for L3? So while you're looking at, you go up onto the title L3 and do L1 minus L2 and hit enter and it should subtract them all. Okay, let's go ahead and write, what would the null hypothesis be?
Difference equals 0.
Right, and that's every time on these. When we're doing matched pairs, we're assuming no difference. So the mean of the difference is 0. Okay, the reason I want to do this, I want to talk about the alternative, how to decide what that's saying. If we look at part C, we're trying to decide if the repair cost for the car is higher. Okay, so if the car is higher, would my difference be greater than or less than 0? Because we did our difference, we did SUV minus car, right? List 1 minus list 2. If the car is more expensive, we would get a negative value. So if your L2 is bigger, that would be less than 0. Does that make sense to everyone?
Where are you getting the part about? In the question it says, does the SUV sustain less? Is that
Right, so
okay.
that's another way. I was looking at part C, but yes, up there in the top it does mention that SUV is less, so. Okay. So now we go to stat, tests, number 2. Okay, we're basing off data, and the null is 0. List needs to be set at L3. Frequency is 1. We don't change that. And we are testing less than. So if we calculate that, what do you guys get for your T value?
-2.6855.
And our P is,
0.011.
in part C it said at the alpha equals 0.05 level, so what would we do? P is less than alpha. Reject the null hypothesis. If I ask for a sentence, there is evidence. Cars sustain more damage. Or SUVs have less damage, or SUVs are safer, however you want to state that.
It's such a weird question because, of course, SUVs can get less damage with way bigger car.
We just proved it. All right. Is that okay? The last one I want to do, I want to look at one that doesn't give us the actual data. So, this is why I started writing my own questions. So I want you to go back a page and look at number 5. It is, your book gets very wordy.
Well, hello? Hello?
But we are going to read through this and pick out our information. Yeah, this is why I've been writing all my questions for the last however many chapters. Okay, so an experiment is conducted in which 16 10-month-old babies were asked to watch a climber character attempt to ascend a hill. On 2 occasions, the baby witnesses the character fail to make the climb. On the 3rd attempt, the baby witnesses either a helper toy push the character up the hill or a hinderer prevent the character from making the ascent. The helper and hinderer toys were shown to each baby in a random fashion for a fixed amount of time. Okay, let's skip over some of this. I really want to get to the second part. A second part of this experiment showed the climber approached the helper toy, and then alternatively the climber approached the hinderer toy, which is a surprising action. Blah 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 blah. So really, the big thing I want is the data at the bottom. It tells us the mean difference in time spent watching the climber approach the hinderer toy versus watching the climber approach the helper toy was 1.4 seconds with a standard deviation of 1.75 seconds. All right, so part A, state the null and alternative hypothesis to determine if babies tend to look at the hinderer toy longer than the helper. So the null hypothesis, we are comparing 2 different scenarios. So babies are watching toys, okay? In one case, a toy is hurting another, in one case it's helping another, or essentially. Huh?
Such an interesting experiment.
Isn't it? So the null is that there is no difference. They spend the same amount of time watching the nice toy as the mean toy. The alternative, we want to determine if they look at the mean toy longer. So that would be greater than, watching it longer. All right, when we go to put this in our calculator, we do not have the 2 lists of times, right? So when we go to stat, test, number 2. All right, we need to now go into stats, not data. So the mean of the null is 0. The x bar is the mean of the difference, which we look in the problem, it tells us was 1.1. Standard deviation, it told us in the problem, was
16 10-month-old babies. I did the same thing.
all right, so the number of babies we looked at
16.
was 16. And we are testing greater than calculate. So we get T now probability did everyone get those? So we don't have the original data. I have to tell you the mean and standard deviation for the difference itself. So part B, we're testing it at the 0.05 level. So what does that mean?
Reject. Will it ever be greater than?
Yeah, I just happened to pick examples that weren't.
Okay.
So, in this case, we got that we reject the null hypothesis. So there is evidence to conclude that babies spend more time watching the mean toy. Alright, so I could give you data, I could give you the numbers.
Wait, this said that they did watch the bad toy longer? Okay.
Yep. Any questions? So I